In this video, we are going to discuss about power diode. A power diode is one of the power semiconductor devices that have two terminals. One is anode and another one is cathode. It conducts current only in one direction, that is from anode to cathode. It is similar to normal PN junction diode, but it is used for high power applications. That is, it can exhibit high power current handling capability. The symbol of power diode is shown here. A is an anode, K is a cathode, and here I is the current flowing from anode to cathode, V is the voltage drop across the diode. Here we will discuss about the difference between power diode and the regular diode. The regular diode can also be called as signal diode, or sometimes it can also be called as small signal diode. So in regular diode, the doping level of both P and N sides is same. Both are doped at the same level, and hence it is called PN junction diode. We will get a PN junction, that is the only junction, and that junction is called as PN junction, and that diode is called as PN junction diode. But in power diodes, we have additional junction formed between heavily doped P plus region and lightly doped N minus drift region. And here is that junction. This is an additional junction, and this is an additional region which makes the difference between power diode and regular diode. Structure of power diode. The structure of power diode is slightly different from the ordinary signal diode. As we have discussed, this N- drift region is an additional region formed in the power diode. And there is a heavily doped N plus substrate. Here you can see this is an N plus substrate with doping level of 10 to the power 19 centimeter per centimeter cube, and this substrate forms the cathode. Here is the cathode. So from the substrate we have taken a terminal as cathode. On the substrate there is a lightly doped N- epitaxial region, and this N- epitaxial region is called as drift region, and the doping level of this drift region is 10 to the power 14 per centimeter cube. And next, a P plus region is diffused into the N- drift region, and the doping level of P plus region is 10 to the power 19 per centimeter cube, and this P plus region forms the anode. Here is the anode, right? And in this process, substrate, epitaxial layer, diffusion, these are the process used in the IC fabrication. So by means of epitaxial growth we are forming N- drift region, and by means of diffusion we are forming P plus region. The thickness of this P plus region is 10 micrometer, and the thickness of N plus substrate is 250 micrometer, and the thickness of this lightly doped N minus drift region depends upon the breakdown voltage of the diode. So the breakdown voltage is the voltage above which the diode will be damaged. Okay, and for higher breakdown voltages the drift region is wide. So if you want a diode, power diode with higher breakdown voltage, and this drift region will be wider so that it can withstand high current. Working of power diode. When anode is made positive with respect to cathode, the diode is said to be forward biased and it starts conducting. So here is anode. When you give positive supply to this anode and when you give negative supply to this cathode, it will be forward biased and the current will be flowing from anode to cathode. Normally a forward bias of 1 volt is sufficient to push the diode into conduction. So if you give 1 volt, then the diode will conduct. Whereas when the anode is made negative with respect to cathode, the diode is said to be reverse biased and it won't conduct. Only a small leakage current flows, and during reverse bias condition, the diode will not conduct. This is the VI characteristics of power diode. So in forward bias condition, the anode current increases linearly with voltage, whereas the regular diode that varies exponentially. So this is varying linearly, whereas the normal diode varies exponentially. So that is also one of the difference between power diode and the normal diode. And this linear rise in this diode is due to the presence of n minus drift region and its ohmic resistance. So because of the n minus drift region, it varies linearly. Okay, so this is the forward bias condition, and here you can see it is varying linearly. In reverse bias condition, there is a small leakage current, and small leakage current is available, and here it is not shown. Okay, and when the reverse bias voltage is greater than reverse breakdown voltage, and this is decided by the n minus drift region. If the drift region is very wide, then this breakdown voltage will be high. Okay, so this breakdown voltage, the reverse after this breakdown voltage, the reverse current increases rapidly, and this diode is not designed for such a high dissipation, the high dissipation and high heat, and the diode will get damaged. So this is the VI characteristics of power diode. Thank you.